In our sky is this one Betelgeuse or Betelgeuse. It's a red giant star. If you put it where the Sun is, it would extend out to the orbit of Jupiter. It's enormous, very unstable, and about to explode. Get ready for a cosmic disaster of never-before-seen scale. Betelgeuse, the red giant star on the edge of our galaxy, is sending scary signs through space. Astronomers have found something deeply troubling about this huge object using the James Webb Space Telescope. Well-known scientist Brian Cox has issued a very serious warning. Are we about to see a supernova explosion that will be so huge that it will change the night sky forever? Let's jump right in. In the vastness of the universe, stars are born, live, and die in amazing ways. Recently, one star has caught the attention and worry of both astronomers and regular people. This is Betelgeuse, a red supergiant star that stands out in the constellation Orion. It is very big and very old. Its unique reddish color and changing brightness have long been interesting, but recent events have made people even more interested in this cosmic giant. As we learn more about Betelgeuse, we are on the verge of a potentially extremely important event in its history. But what might these changes in Betelgeuse mean? Are we seeing the start of a cosmic show on an unimaginably huge scale? Betelgeuse is a stellar giant, about 764 times bigger than our Sun. It is so huge that it's hard for humans to understand. Imagine a star that is so big that if it were to replace our Sun, its surface would reach beyond Mars's orbit and wrap around Mercury, Venus, Earth, and Mars. This huge size shows how amazing Betelgeuse is physically, and also shows what stage of its life cycle it is in. As a red supergiant, Betelgeuse is nearing the end of its life. It is expanding and cooling during this phase, which comes after turning hydrogen into helium in its core. This star is thought to be between 8 and 8.5 million years old, which is pretty new in human years but very old in terms of stellar lives. It has changed dramatically over millions of years, going from a hot blue star to the red giant we see today. It is now in its final stage as a red supergiant. Stars like Betelgeuse change over the course of their lives, caused by the constant pressures of nuclear fusion and gravity. Another thing that makes this stage of Betelgeuse stand out is its unique reddish color. Its red color comes from the fact that its surface is cooler than the surfaces of other stars like our Sun. The surface of the Sun is about 5,500 Kelvin hot, while the surface of Betelgeuse is about 3,500 Kelvin cold. Because it is cooler, Betelgeuse can give off light at wavelengths that make it look red. This color isn't just a look, it tells us something about the star's physical state and the processes going on inside its huge gaseous volume. The fact that Betelgeuse's color has changed over time adds to its mystery. Writings from the Roman and Chinese eras say that Betelgeuse was yellow about 2,000 years ago. In the 9th century, Arabic experts were the first to say that it was red. This change in color over the course of human history is not just a small fact in the history of science, it also shows how the star evolved. Another interesting thing about Betelgeuse is that its brightness changes over time. It's a semi-regular variable star, meaning that its brightness goes up and down on a regular basis. This dance of brightness has fascinated scientists and skywatchers for hundreds of years. Usually, Betelgeuse goes through a 400-day cycle and a longer cycle that lasts for 5 years. As early as 1836, Sir John Herschel wrote about these cycles, and Aboriginal folk histories may go back even further. But what really makes Betelgeuse mysterious is not just how its brightness changes, but also how uneven it is. Unlike many stars that dim and brighten in a predictable way, Betelgeuse sometimes deviates from this pattern. This suggests that complicated and less well-understood processes are happening inside its huge form. Recently, astronomers and stargazers all over the world were shocked to see Betelgeuse's appearance change dramatically and unexpectedly. This is now known as the Great Dimming. In late 2019, the red supergiant Betelgeuse, one of the brightest stars in the night sky and a prominent feature of the constellation Orion, started to dim in a mysterious way. The star was getting so dim that it started losing its light at a rate of 0.01 magnitudes per day on average. In February 2020, it was at its dimmest. Betelgeuse, which can usually be seen with the naked eye even in places with a lot of light pollution, got much fainter, and even casual viewers could see the difference. The time paradox, on the other hand, makes it hard to keep an eye on what Betelgeuse is doing because light takes so long to get to us. When we look at a star like Betelgeuse, we don't see it as it is now but as it was in the past. For Betelgeuse, the light we see today left the star almost 700 years ago because it is about 725 light-years away. Because we are looking into the past of the star, this time lag makes it hard to predict and keep an eye on quick changes in its behavior. The Betelgeuse dimming event was a reminder of how hard it is to observe the sky in real time and how little we know about the big, strange worlds of space and time that they create. Andrea Dupree, Deputy Director of the Center for Astrophysics at Harvard and Smithsonian, and her team closely watched the events of Betelgeuse's celestial drama as part of a 3-year study to track changes in Betelgeuse's outer atmosphere. They used Hubble to look at the huge star. These observations gave a new look into how a variable star like Betelgeuse works. Variable stars regularly get bigger and smaller, which causes changes in how bright they are. Researchers were able to look into the layers above the star's surface, which were heated in part by the star's swirling convection cells, thanks to Hubble's sensitivity to ultraviolet light. More study of the Hubble spectra, which were taken at different times in 2019 and 2020, helped figure out how fast things were moving in the upper atmosphere of Betelgeuse. The spectra were mostly made up of magnesium-2 lines, which show what the star's atmosphere is like. The studies showed that things were moving from the star's surface into its atmosphere at about 200,000 miles per hour. This hot, dense stuff finally reached millions of miles away from Betelgeuse. It was the start of the dust cloud that made the star less bright during the 3 months of the outburst. Dupree and her team thought that about twice as much material as usual from Betelgeuse's southern hemisphere was lost. While all stars lose mass over time, Betelgeuse's loss was especially noticeable because it happened at a much faster rate than the Sun's. Astronomers talked about weather. This event could be a sign of a supernova explosion because of how big this mass release was and how dim it became afterward. Being only about 725 light-years away from Earth, Betelgeuse adds to the mystery because any explosion like this would be visible from Earth and give people a rare chance to see a supernova up close. But the question still stands. What does this dimming mean for Betelgeuse's future? Is it a sign that a supernova is about to happen, or is it just a one-time event in the star's long and complicated life? Several ideas were put forward to explain this quick change. One popular theory said that there was a stage in the process of a supernova explosion. This idea caught on because most people think that Betelgeuse is almost done with its life. Another common idea is that dust, maybe from the star itself, is blocking our view. It is known that Betelgeuse and other red supergiants lose stuff. It was thought that this stuff could build up into a dust cloud thick enough to block our view of the star's light. A third idea looked at how changes in the star's photosphere, the visible layer on the outside, might have an effect on how bright it seems. This puzzle was solved by using a lot of different observational methods and in-depth analysis. Spectroscopic studies showed that Betelgeuse's effective temperature dropped. This suggests that the star may be dimming because of a big dark spot on its surface. The fact that Betelgeuse's temperature dropped by at least 170 Kelvin around the time of the dimming supported this idea. This showed that there were big changes on the star's surface. In the end, the Hubble Space Telescope, which is humankind's watchdog in space, helped us figure out what was going on with this strange event. Hubble's views showed that the dimming of Betelgeuse was probably due to a large amount of hot matter being thrown into space. This stuff made a cloud of dust that covered up some of the star's surface, which meant that less light from Betelgeuse reached us. It was thought that the dust cloud was made of very hot plasma that erupted from a big convection cell on the star's surface and moved through its hot atmosphere to the cooler layers on the outside. It formed dust grains as it cooled, making a cloud that blocked light from about a quarter of the star's surface. Hubble's ultraviolet light spectroscopic studies, which began in January 2019, were very helpful in putting together the events that led to Betelgeuse getting darker in the months before the dimming. These studies showed signs of dense, hot matter moving through the star's atmosphere. After this, in September, October, and November 2019, Hubble took more UV spectra, which showed that the star's outer layers were getting stronger. Astronomers now think that a lot of hot plasma left Betelgeuse in the fall of 2019. This hot plasma moved through the star's atmosphere, eventually turning into dust grains that caused the Great Dimming. The Great Dimming showed how important it is to keep an eye on changes in the sky, and how our understanding of the universe depends on careful, precise studies. Betelgeuse, a changing and unpredictable star, showed how powerful telescopes and new ways to look at stars can help us learn more about them. This gives us a peek into the complex systems that power the stars. Even though Betelgeuse was scary, it also gave us a chance to learn more about the processes that drive stellar evolution. This added to our knowledge of the universe's big, dynamic systems. As Betelgeuse's journey continues, the Great Dimming will be remembered as an important chapter that showed how astronomy and our search for answers about the cosmos are always changing. Supernova, the beautiful death of a star. Even though Betelgeuse hasn't reached this point yet, its changes point to the future. As Betelgeuse continues to move toward the end of its life, its destiny as a possible supernova becomes clearer. When a red supergiant like Betelgeuse runs out of fuel, the end will be marked by a supernova, one of the most powerful explosions in the universe. This could happen tomorrow or in 100,000 years. In a supernova explosion, the core of the star will collapse under its own gravity, sending a shockwave through the star's outer layers. This will cause a huge explosion that will send heavy elements like oxygen, carbon, and iron into space. The shockwave and the light show from a supernova explosion would be seen in our skies for weeks or even months. If a star went supernova, the amount of light it would give off would make it look like it was daytime even at night. But a supernova isn't just a light show, it would also change the area around it. When Betelgeuse goes supernova, it will send a lot of energy into space. This will change the interstellar environment. This could affect the formation of new stars and planets in the area. Even though supernova explosions are powerful, the explosion itself is far enough away that it wouldn't be directly dangerous to Earth. Still, it would be an interesting event for scientists and the public to watch. It would be a once-in-a-lifetime chance to learn more about how stars die and what happens when they explode. As we continue to look at Betelgeuse and wait for it to end, we are reminded of how vast the universe is and how powerful the forces that shape it are.